This sound file contains the spoken version of the Wikipedia article on icing conditions. The material was recorded on December 7th, 2017. Icing conditions from Wikipedia, the free encyclopedia at en.wikipedia.org. In aviation, icing conditions are those atmospheric conditions that can lead to the formation of water ice on the surfaces of an aircraft or within the engine as carburetor icing. Inlet icing is another engine-related danger, often occurring in jet aircraft. These icing phenomena do not necessarily occur together. Many aircraft, especially general aviation aircraft, are not certified for flight into known icing conditions certain or likely to exist based on pilot reports, observations, and forecasts. Section 1. Definition. Icing conditions exist when the air contains droplets of supercooled liquid water. Icing conditions are characterized quantitatively by the average droplet size, the liquid water content, and the air temperature. These parameters affect the extent and speed that characterize the formation of ice on an aircraft. Federal aviation regulations contain a definition of icing conditions that some aircraft are certified to fly into. So-called SLD, or supercooled large droplet, conditions are those that exceed that specification and represent a particular hazard to aircraft. Qualitatively, pilot reports indicate icing conditions in terms of their effect upon the aircraft and will be dependent upon the capabilities of that aircraft. Different aircraft may report the same quantitative conditions as different levels of icing as a result. Section 2. Types of structural ice. Clear ice is often clear and smooth. Supercooled water droplets or freezing rain strike a surface but do not freeze instantly. Often, quote, horns, unquote, or protrusions are formed and project into the airflow. Rime ice is rough and opaque, formed by supercooled droplets rapidly freezing on impact, forming mostly along an airfoil's stagnation point. It generally conforms to the shape of the airfoil. Mixed ice is a combination of clear and rime ice. Frost ice is the result of water freezing on unprotected surfaces while the aircraft is stationary. This can be dangerous when flight is attempted because it disrupts an airfoil's boundary layer airflow, causing a premature aerodynamic stall, and in some cases, dramatically increasing drag, making takeoff dangerous or impossible. SLD ice refers to ice formed in supercooled large droplet conditions. It is similar to clear ice, but because droplet size is large, it extends to unprotected parts of the aircraft and forms larger ice shapes, faster than normal icing conditions. This was a factor in the crash of American Eagle Flight 4184. Section 3. Effect. The wing will ordinarily stall at a lower angle of attack and thus a higher airspeed when contaminated with ice. Even small amounts of ice will have an effect, and if the ice is rough, it can be a large effect. Thus, an increase in approach speed is advisable if ice remains on the wings. How much of an increase depends on both the aircraft type and amount of ice. Stall characteristics of an aircraft with ice-contaminated wings will be degraded, and serious roll control problems are not unusual. The ice accretion may be asymmetric between the two wings. Also, the outer part of a wing, which is ordinarily thinner and thus a better collector of ice, may stall first rather than last. Section 4. Icing prevention and removal. Several methods exist to reduce the dangers of icing. The first and simplest is to avoid icing conditions altogether, but for many flights this is not practical. If ice or any other contaminants are present on an aircraft prior to takeoff, they must be removed from critical surfaces. Removal can take many forms. Mechanical means, which may be as simple as using a broom or brush to remove snow. Application of de-icing fluid or even hot water to remove ice, snow, etc. Use of infrared heating to melt and remove contaminants. Put the aircraft into a heated hangar until snow and ice have melted. Position aircraft towards the sun to maximize heating up of snow and ice-covered surfaces. In practice, this method is limited to thin contamination by the time and weather conditions. All of these methods remove existing contamination, but provide no practical protection in icing conditions. If icing conditions exist, or are expected before takeoff, then anti-icing fluids are used. These are thicker than de-icing fluids and resist the effects of snow and rain for some time. They are intended to shear off the aircraft during takeoff and provide no in-flight protection. To protect an aircraft against icing in flight, various forms of anti-icing or de-icing are used. A common approach is to route engine, quote, bleed air, unquote, into ducting along the leading edges of wings and tailplanes. The air heats the leading edge of the surface and this melts or evaporates ice on contact. On a turbine-powered aircraft, air is extracted from the compressor section of the engine. If the aircraft is turbocharged piston-powered, bleed air can be scavenged from the turbocharger. Some aircraft are equipped with pneumatic de-icing boots that disperse ice buildup on the surface. These systems require less engine bleed air, but are usually less effective than a heated surface. A few aircraft use a weeping wing system, which has hundreds of small holes in the leading edges and releases anti-icing fluid on demand to prevent the buildup of ice. Electrical heating is also used to protect aircraft and components, including propellers, against icing. The heating may be applied continuously, usually on small critical components such as pitot-static sensors and angle of attack vanes, or intermittently given an effect similar to the use of de-icing boots. In all these cases, usually only critical aircraft surfaces and components are protected. In particular, only the leading edge of a wing is usually protected. Carburetor heat is applied to carbureted engines to prevent and clear icing. Fuel-injected engines are not susceptible to carburetor icing, but can suffer from blocked inlets. In these engines, an alternate air source is often available. Note, there is a difference between de-icing and anti-icing. De-icing refers to the removal of ice from the airframe. Anti-icing refers to the prevention of ice accumulating on the airframe. This sound file and all text in the article are licensed under the Creative Commons Attribution Share Alike 3.0. Unported license. Available at http://creativecommons.org/licenses/by-sa/3.0.